Welcome to lesson number 6, the inverse of relation. Alright, so like I said in class, this lesson is going to be a little easier than the last few. So it'll be a nice time for you to just take a little break and just enjoy, doing something a little less complex. Alright, so if I have a function, remember a function is a relation in which each element of a set A, or your domain, so we could also refer to those as our x's, is mapped to one element of a set B, or my y, which is also my range. And so if I'm looking at these examples here, if I have my values of x, or A, and my values of B, or y, then each of these are values of x's. So 1, 2, and 3, and 4, those are values on my x-axis. 2, 4, 6, and 8 are values of on my y-axis. And so if I wanted to plot these, this would be at 1 and 2, this would be at 2 and 4, this would be at 3 and 6, and this would be at 4 and 8. Now, it's also telling me that my values of x are half of my values of y, right? So 1 is half of 2, 2 is half of 4, and 3 is half of 6, and 4 is half of 8. Okay, so that makes sense. Now let's look at the inverse of this function. So what the inverse is kind of the opposite. So the inverse of a function is a relation which undoes what the function does. In other words, the elements in set B are put back to set A. And so if I'm halving 1, 1 is half of 2, 2 is double of 1. And so these sets would look like this: 2 and 1, 4 and 2, 6 and 3, and 8 and 4. And so if I were to half a number and then double it, it's just going to put it back to what the number was originally. So that's what we do when we have the inverse of a function. Now let's look at the second set. Remember, a function is a relation. So all these numbers are relations, and so are these ones. They're all related to each other somehow, but they're not both necessarily functions. Alright, this is a function and this is a function, and I'll show you why, but this second set, they aren't actually functions. And so if I have my set of numbers A and B and A, this set down here is going to be the inverse of my top set. And so these are my values of x and my values of y. And so what I'm doing here is I'm squaring these. And so these numbers are the square roots of my y values. Alright? And so I'm at negative 2 and 4 and 2 and 4, negative 3 and 9, and 3 and 9. But since a relation is a function which each element of set A is mapped to one and only one element of a set B, this is actually mapped to two elements here, as is this one, as are these down here. And so they're not actually functions. So in each case above, complete the following by choosing the correct answer. In case 1, the inverse is a function, but in case 2, on this side and this side, it is not a function. And remember, back to Math 10, you can also determine this by using a vertical line test. So if I have a function that looks like this, and I draw a vertical line through it, if this vertical line only fits one value of x, then it is a function. But if I perform another vertical line test, and let's say I had something that looks like this, so a relation that looks like that, and I draw my vertical line through it, since it passes at 2 points for my y value at the same x value, it is not a function. Okay? So let's think about a little more. So the domain of the inverse is the range of the original function. So essentially your x and your y switch places. So the range of the inverse is the domain of the original function. So again, my y's and my x's switch places. And so the inverse of a function may or may not be a function. Now when you're talking about operations, remember that that's with like adding, subtracting, multiplying, and dividing. So finding products, quotients, sums, and differences. Consider the operation. So if you were to do this in the morning, you put on your socks and then put on your shoes. What is the inverse of that operation? Well, it would be to do the opposite. So if you start with putting on your socks, then you put on your shoes and you want to go backwards to back to bare feet, then you're going to take your shoes off first and then your socks. Take shoes off and then socks. Alright, so that would be the inverse of that first operation you performed. Now with our function inverse, if I multiply something by 2, how would I undo that? Well, I would undo that by dividing by 2. If I were to square something, I would square root that. If I were to take the reciprocal, so remember 1 over 2, I would do the same thing. I'd take the reciprocal of 1 over 2, and I'd take the reciprocal again, and that would put it back to my original. If I were to divide by 3 then add by 1, well, I would have to multiply by 3 and then subtract 1. Now I have to look at all these and determine whether or not they're functions. Well, if I multiply and then divide, the inverse will still be a function. But just like we determined beforehand, if I square something and then square root it, I'm not left with a function. If I take the reciprocal of reciprocal, we've done that in math or pre-calculus 11, and it is a function. And this is just like taking a linear equation, and that will still give us a function. Okay, so let's look at this next section here. How do I find the inverse of a function defined by the ordered pairs? Well, let's see this. Let's look at this first line. Remember, these brackets here just mean that we're working with a set of numbers. Okay, so let's look at our number sets. This first set of numbers, well, I'm going to be at 1 and 2, but the next one is going to be at 2 and 4. Now I know this by recognizing that these are my x values and these are my y values. So I got 2 and 4. My next set will be 3 and 6. And my final set is going to be 4 and 8, or my final pair. Alright? Now, if I were to do the inverse of these, all I'm doing is I'm switching my x and y values. So since 1 is an x value, it now becomes my y value. Since 2 is my y value, it becomes my x value. So I'm going to do the same thing on this side. So that'll become 4 and 2, 6 and 3, and 8 and 4. And if you look at what I have down here, remember that all my x values were half of my b values, but now my b values are double my x values. Alright, so notice that they can be, you can get your inverse pairs by just interchanging your first and second coordinates for your x's for your y values. And that's also going to reinforce that your domains and ranges are just going to be flipped. Alright, so let's consider this function defined by the following set of ordered pairs. So first I'm at -4 and -2. I'm at -2. Oh, sorry, that was not where that point is. I'm at -4 and -2. I'm at -2 and -1. I'm at -1 and 0. 0 and what am I doing? Hold on. Let's start this again. So I'm at -4, -2, -2, -1, -1 and 0. There we go. 0 and +1. I'm at now 2 and 4, and I'm at 3 and 8. Yeah, sorry about that, you guys. I kind of dropped the ball that time. Okay, so that's what my line is going to look like. Now I want to describe the inverse of the function by the set of ordered pairs. And so what this is going to become is -2 and -4, -1 and -2, 0 and -1, 1 and 0, 4 and 2, and 8 and 3. Alright, and so I'm going to plot this in a different color now. So, -2 2 and negative 4 is going to be down here. That's what I was looking at earlier. Negative 1 and negative 2 will be here. 0 and negative 1, 1 and 0, 4 and positive 2, and 8 and 3. So my inverse function is going to look kind of something like that. Okay, so I graphed it. Now we want to draw a line that's going to act as a mirror. Well, my mirrored image is just going to be at y is equal to x. And so it's just a y is equal to x. It's just an equation that's going straight through my origin, and it has a slope of 1. Okay, now, to determine the inverse of a function defined by a graph, reflect the function in the line at y is equal to x. Alright, alternatively, you can select the coordinates of some key points and interchange the coordinates and plot some new points. So next, let's sketch the graph, the inverse of this equation of the function defined by the following graphs. And then we want to determine whether or not it's an inverse function. Alright, so if I'm at 0 and 2, 4, 6, this new function is going to be at 6 and 0. Okay, so 2, 4, 6. This is where my new line would be, and maybe I should something like that. Okay. If I'm at 1, 2, 4, 6, and 0, this is now going to be at 0 and 6. And this line here is going to be at negative 6, 2, 4, 6, negative 6, and 0. So we're going to be at 0, 0, and negative 6. And this function at 0 and 6 will be at 6 and 0. Alright, so this is what our function is going to look like. It's going to go something like this and something like that. And let's see if it is a function. Well, it does not pass my vertical line test, so not a function. Not a function. Now let's look at the second line. If I'm at, again, at 2, 4, 6, at negative 6 and 0, this is going to become 0 and negative 6, 2, 4, 6. At this point here, I'm at 0 and 4. I'm going to now be at 4 and 0. And at this point, I'm going to be at 2, 4, 6, 6 and 0. It's going to become 0 and 6. So 0 and 6, like this. And so this line is going to look something like a half moon, like that. And again, it does not pass my vertical line test. And so it is not, neither of these are functions. And finally, let's look at example 5. When finding the inverse of a function, and all we're doing with our equation was we were interchanging our x and y values before. Now, if we're given an equation, to find the inverse of that equation, we do the same thing and we flip our x and y values. And so if I were to find an equation in the form y equals mx plus b for the inverse of the function, then the inverse of y equals mx plus b is x is equal to my plus b. And so the inverse function for this is going to be, for y is equal to 3x plus 2, is going to be x is equal to 3y plus 2. Okay, so if I compare these two, all I did was switch my x and y values. And now I need to solve for x. or sorry, solve for y to get it by itself, so I can graph it. And it's going to look something like this. I'm going to have to get this 3y over here. So negative 3y is equal to negative x plus 2. I'll divide by negative 3. Y is equal to 1/3 x minus 2 over 3. So what I want to do now is graph the original and its inverse. Okay, so my original graph is something like this. I'm starting at 2, and I have a slope of 3. And so it's 1, 2, 3, like that, and 1, 2, 3, and down there. So this is my original line. Okay, so this was 3x plus 2, y equals 3x plus 2. And my new line is right here. Y is equal to 1/3 x minus 2/3. And so 2/3 is somewhere around here. I'll use a black pen. And I'm going up by 1 and over by 3. 1, 2, 3. Down by 1/3 and over by 3. So this is my new line. Okay, so is the inverse of the graph of the function defined by the equation y equals 3x plus 2 also a function? The answer is yes, and we know that because it does at any point on this new line, my inverse function will follow the vertical line test. Alright, this is the last page here. I just encourage you guys to try the last example by yourself and do so by using this graph here, okay? Or using these instructions on your graphing calculator. And again, if you need support with this, I will help you with this in class.